Hello, welcome back to my YouTube channel, Social Data Analysis, number one stop channel for quantitative research and data analytical software tutorials and everything about analyzing that data that you love so much and drawing amazing insights from it. So, in our previous video, beginner lesson 101, we spoke about how to create objects in R, right? And then we said an object was any concept that you would use to store other forms of data, right? So remember we said that if you had an X and you assigned some information to it, let's say 2 plus 2, then your X should be able to store the value of 2 plus 2, right, which is 4, right? So anytime we called X and then we run it, we should be able to get 4, right? Now there's nothing magical about X. It could be anything else. It could be Y, right? It could be Y, and then it's storing some information called, let's say, Apple, right? If I called Y, I should be able to see apples in there. So there's nothing magical about X or Y. It could be anything else. It could be anything. Now, remember in the previous video, I mentioned that anytime you wanted to use the information in a particular object, you have to just call the object. It also means that you can do any arithmetical operation with the same objects, right? So for example, we already have a variable called x, which has 2 plus 2 in there. Let's create another variable called, let's say, Joseph, right? Or an object called Joseph, right? And Joseph has 10 in there. If I do Joseph plus x, I should be able to get 4 plus 10. Why? Because x has the value of 4 embedded in it, and Joseph has 10 assigned to it as well. So the R software doesn't see Joseph, it doesn't see x alone, it also sees the values embedded in them. So let's run this and see what we're gonna get. Great, right? We got 14, and that makes sense because Joseph has the value of 10 embedded in it, assigned to it, and X has the value of 4 assigned to it. It means you can do any calculation that you want with this, right? All right. I could also do a division operation, and then it makes a lot of sense. So that is one thing to keep in mind with objects. We're going to use objects throughout, and you can use objects just the same way you use everything else, right? That is great. Now let's talk about data types. The calculations you do in R and the results you get, the interpretations you make from them depends on the data type. And that is not just R, it applies to every other statistical software. And then it's sort of a basic principle in quantitative research. Your data type tells the type of analysis you can make. There are four data types, right? There are four data types in R to use, and as I said, it mostly applies to most of the statistical packages, just that sometimes they give it different names. Now let's start from the first data type called the numeric data type, right? So the numeric data type, as probably you know already, contains any numeric value, right? And it could include even decimals. So the numeric data type can be 4.2, 4.2, it can be 5.3, so on and so forth. So there are more of continuous variables that can assume every value. Now let's practice this with our newfound skills in objects at the same time, right? So let's create an object called numeric, right? And then let's save some numeric data in there, right? Yeah. Now let's talk about another data type, integer, another data type in R, right? And an integer is basically whole numbers. So anything 5, sorry, 4, 5, 54, 54 works, 60, 68, anything like that is an integer, right? Let's store this data. So now I'm intentionally creating an object called integer, and I'm storing this information in it, right? But you could create an object with any name at all. That is totally fine. Now let's create an object with another data type, and this data type is the string data type, right? String. Okay, so a string is basically something that contains words or something alphabetical. So if you had a data like Joseph, boy, girl, football, anything alphabetical is a string. And in R, you need to tell R that your data is a string. You need to tell R that your data is not a number and that R should treat it as a string. If you do not do that, R is going to label that particular line of code as an error. So as you can see on code line 1, you can see that there's an error here because R doesn't understand why I wrote data types but I didn't put it in quotation marks, right? So quotation marks are very, very important when you use strings. You have to include it. So if I wanted to create, now I'm creating an object, I'm gonna call a string, right? By what it is, it contains some information like football, and it has to be around quotation marks. Now single quotes are allowed, double quotes are also allowed, right? Single quotes are allowed, double quotes are allowed. So you have to know which one you're using, but you cannot use them interchangeably, right? You have to use either of them, but you can't use them interchangeably. All right, now let's look at the last data type, and the last data type is the logical. Yes, so the logical is basically true or false, right? Is it true that 4 is greater than 2? Or is it true that 10 is greater than 20? That is false, right? So basically logical is either true or false values in R. And how you use it, it's giving R different sort of data to compare for you, or asking R a new question and R is going to return for you true or false. And you could also have a data set that has true or false, or you could use true or false in exactly the same way that we have the other type of data type. So I'm going to assign this object I have here false, right? So the logical is dichotomous. It means it can only have either true or false, and it can't vary more than that. So I have these four data types that are in R. I created objects in their names, and I stored information or data that has something that reflects that data type into these objects. Now let's run it in R and then see what we have. Okay, so it's in there. Now, if we were to call numeric, what would R give us, right? It says 4.5, the exact information we gave it, right? That is cool. Anytime I wanted to use that information, I would just call numeric. All right. Now, the same thing applies to all the other objects that we created. So for example, if I called logical, for instance, it is going to return false because we created an object called logical and then we stored false in it. That is great. So let's move on to doing other cool stuffs with this new knowledge that we found. Now we know 4 data types in R. Now, assuming, right, that you found a variable or you found an object that you were not sure what the data type is. How are you gonna find that information from R? So for example, I created this object called Joseph, but I'm not quite sure what Joseph contains. Is it containing numeric value? Is it containing integers? Blah blah blah. Right? So this is where I introduce you to functions. Now there's a function in R called class. Now what a function class does is that it reveals to you the data type of the object that you have in R, right? So if I called class, right? So to use a function in R, you call the function inside parentheses. So if I called the function class and I said, what does Joseph contain? So if I called the function class and I said, what does Joseph contain? Now remember, I would have to save this information in some variable that I would later call the variable. So I'm gonna save it in a variable or an object called z, right? And I run it, right? And I say, okay, what is z? It tells me that z is numeric. Now, why does z contain this information, and why is the information in inverted commas? It's because it is not data that I have given to z. It is a question that I asked R, that I have a variable called Joseph and I don't know the data type. So use the function called class to reveal to me what data type Joseph is and assign that information, whatever the information is, to z. So anytime I call z, I'm going to get what data type Joseph is, right? So let's look at the other data type. Now I'm going to override the same z that I created, and I want to find out the data type of the logical object that we created. Okay, so what we have in z, R tells me it's a logical data type. So that is how you can find out the data types of your variables or your objects in R. All right, cool stuff. Yes, if you were wondering about the data types in R, these are the data types, right? The next video, we're going straight into using these different types of types to do computations in R. Thank you, and see you in the next video.